Hello everyone, good morning. Are you able to hear me? Oh, okay. Yeah. So today we will discuss about data frames operations. The remaining transformations we will discuss, and then we will quickly jump into the use case on data frames. Okay. So these are the two things that we're going to discuss today. Let me quickly share my screen. Meanwhile, let me see if I have cluster available. Otherwise, I'm God. Okay, so I have the cluster ready. So let me quickly share my screen. Okay, so in our previous session, we have seen different transformations on data frames. Today we will see the analytics functions, right? So how we will apply row number, how we will apply rank, dense rank for the data, all these analytics functions. So lead and lag also will be supported in Spark data frames. Okay, all the SQL transformations that you or already experienced. So those analytics transformations, everything will work on Spark data frames. So we just need to know how actually we can implement them. And today we will also see one more thing, how we can execute SQL queries on Spark data frames. So that is another thing that we will discuss today. Uh, let's quickly understand how we can do that. So I have my cluster ready. So I'm just trying to open the PySpark shell. Okay, so we have seen till pivot. Okay, so let us try to understand how we can. Okay, so let us try to understand how we can run SQL queries on top of the Spark data frames, right? So here, if you see, I have data and I have columns, and I'm just passing it to DF, and then I'm just creating the data frame. People. Okay, okay, I got it. So 1 second. So let me quickly run this. So let me. So here what we are doing, we are simply taking some data and we are trying to create a data frame for that data, right? Okay, so now our data frame got created. So now what we need to do, the next step is you need to create a temporary logical table on top of this data frame. Then only you can apply SQL queries. Okay, so what do I mean by that? See here, so df dot create or replace temp view. Okay, so here if you see, I'm just giving my name. So my name is going to be people, let us say. Okay, so this statement got executed. Now you can run all your SQL queries on top of this temporary table that you got created. Okay, on top of the temporary table that you got created. So this is the process to run your SQL queries on top of your data frame. Okay, so what is that? So you need to create a temporary view on top of your data frame. Okay, and then call that view as a table in your data frames. Okay, call that view in your query as a table, and by using spark.sql. So this is the method that we need to use to run your SQL queries. Okay, this is a very simple query, but even if you have very complex queries, you just need to prepare your query string and pass it to your spark.sql method. Okay, so people who are not very much comfortable with the normal data frame based functionalities, or else native SQL based transformations, they can actually go for this SQL based transformations also. Okay, so you can test this first name. See here. So you can write any SQL query in this string. Okay, the process is you need to create a logical temp view on top of your data frame, and on top of that temp view you can write your SQL queries by using spark.sql method, and the results you can always return to a data frame again. Guys, are we clear on how to run SQL queries on a data frame? This is a very good feature for people who are not programmatically good, who are good with SQL skills. They can directly write SQL queries on top of the Spark data frame. Okay, so Anusha, Prakati, and Rangnath, are we good with this?
Yes,
Any
Venky.
questions or queries?
Yes, Venky.
Yes, Venky.
Okay, okay, fine. So now let's move on to the next concept, which is actually the analytics functions. Okay, so let us quickly understand these analytics functions. So first we will discuss about row number. Okay, so row number functionality. So we know what is a row number functionality, right? So in SQL sessions we have discussed about it. So here if you see what I'm trying to do, let us observe the window functions. So first I'm trying to import the Spark session. Okay, object from PySpark.sql, import Spark session. This is the object that we need to import to create the Spark session. Okay, and then we need to import a new function called window. Okay, to apply the analytics functions like row number, rank, dense rank on top of a Spark data frame, you can actually import a window function. Okay, so this is a window function that we need to import. Okay, then you need to import all the functions from Spark SQL dot functions. So these three things are very important when you are writing Spark applications. So from PySpark SQL functions, you need to import every function that is needed, and window function you need to import, and then Spark session. Okay, once you have it, then preparing our data. So we know how to create a data frame from the normal uh, Python data collections, right? So we prepared our data. So here if you see employee name, department, and salary. Okay, now so what we are trying to do, so we are trying to create a data frame out of this data, and we are trying to declare our window function. See here, this is very important. Okay, your window function is a variable of window object type. Okay, so whatever you imported as window, it will give you the few methods, inbuilt methods. Okay, so window dot partition by the department, order by salary. Okay, so here if you see, this is how you declare your window function. Okay, Now again, how we can use this window function in row number, right? So similar to SQL, what we do, we have a row number function under spark.sql functions. Okay, so that row number function dot over. So here in SQL also we will specify over clause, right? So rank, row number, over, inside over we will specify partition by and order by clauses, right? So similarly here we will specify that partition by and order by in a window function. Okay, so that window function we will pass in the over class, that's it. Okay, so then we can simply see the new column that is created with the row number, right? So this is how you will apply your row number functionality on Spark data frames. Okay, fine. So next we will look into the next transformation. We have rank and we have dense rank also. Okay, so see here, so I'm just trying to call the same window function, and I'm just adding rank and dense rank also to the data frame. Okay, see, this is my rank and this is my dense rank, right? So this is how you will apply your analytics functions on top of your Spark data frames. Okay, so any questions here, guys? Any questions in analytics functions as well as writing SQL queries on data frames? Any queries? No, right?
Clear.
Okay, fine. So we have one more concept that is needed for our Spark programming purpose. Okay, so I will try to explain you that concept. So what it is, SQL data frames and data sets. Yeah. Yes, let's adapt to query. So along with the other concepts that we are talking about, right? So we may need to also understood about Spark configurations. So this is very important. Okay, so I will try to come to this concept later, but let us try to understand. There are a couple of concepts actually, so let me try to find them. So you can actually refer to this documentation, you will find the complete guide for Spark. So there should be a concept called cache and persist. I'm just looking for that. Okay. Okay, so these are under RDD programming. Okay. Okay, fine. So let me explain the concept for you guys. Okay, so the background for it is the performance optimization of your Spark jobs. So let us take an example. Let me explain you how actually this performance tuning will help in real time projects. So basically, let us take an example. You have a Spark data frame. Okay, and we know this data frame is distributed across all the nodes. Okay, so just give me a minute, guys. Join meeting. Okay, so we know this data frame is distributed, right? So let us take an example. Your cluster or else your worker nodes. Let's see. Okay, so okay, so your worker nodes have partitions. We know. Okay, so and these partitions will be executed by your executors. Correct. So when they are executing, the executors, let us say you combinedly, let us take an example, you have 10 GB of partitions in this node. Okay, so 10 GB of partitions, and your RAM is only 2 GB. Okay, in this executor you have given 2 GB RAM. Okay, so will this run at all? Your executor will run at all, or what will happen? Out of your understanding, tell me. Answers, guys. Let us say you have 10 GB worth partitions. Number of, I mean, multiple partitions are there, and your executor RAM is 2 GB. Okay. Now, what will happen? Will it fail or will it process? Come on, guys. Answers. Okay, fine. So let me explain you here. So it won't fail, guys. So it will take more time because it will read partition level into the in memory. It won't read all the data at once to the memory. Be very very clear. Okay, so it will try to read only the partition level data. Okay, so then it won't fail. It will take more time. That's it. It is not like, okay, so you have 2 GB executor memory, you won't be able to process 100 GB data. No, your Spark job can run, but it will take a lot of time. That's it, because it has to go and read uh, partition by partition, right? So in that scenario, if you want to persist your entire data into the RAM, or else if you want to store your entire data into the RAM, then you can use a method called rdd.cache or dataframe.cache. Okay, so that is the method that we have to store your entire data into uh, in memory. Okay, so cache is a method that we will use to store entire data into the RAM. Okay, and there is one more method called persist. Okay, there is one more method called persist. So these two methods will store your data into the RAM. Okay, now if you want to load everything at once into the RAM, your RAM, I mean, also have that capability or capacity to store this data, right? So now your cache, if you are doing, it will store only everything into the memory. Okay, but your persist will give you a lot of options. Your persist can store your data in memory, or it can store data in memory and disk. It can store disk only. Everything it will do. So that means your persist will give you different storage level options, but your cache won't give multiple storage options. So it will give only one option, that is memory only. It will store data into memory only, in memory only. So now when to use which functionality? Let us take an example. You have a source data frame. Okay, and you are using the data frame multiple times in your program. Okay, multiple times, or multiple functions are calling the same data frame again and again, right? So in that scenario, you can actually use cache. Okay, you can actually use method to load the data frame to in memory, so that multiple times it won't be able to, it does not needed to read it from the disk, right? So it can directly available, it is directly available to the memory. So it can directly read it from that memory. All right, so that is the importance of cache. But persist is something that wherever you need, let us take an example. You are not sure, if you cache everything, you are not sure whether your memory will suffice or not, right? So in that scenario, your persist storage levels will help you out. Here if you see, you have different storage levels. Okay, so memory only, memory and a disk, memory only serializer, memory and disk serializer, disk only. So these are all different options that your persist method will provide. Okay, so you just need to call persist of storage level dot memory only. Okay, you just need to call this. That's it. Okay, so this is how, I mean, your persist and cache will work. Okay, and you also need to understand two more configurations. One is Spark SQL shuffle partitions. Okay, so there are multiple configurations, guys, in your Spark performance tuning, data frames performance tuning. If you go and see, right, so here you'll just go to the performance tuning, right? So in this performance tuning, you can actually see hell lot of Spark configurations. These configurations are very important. You need to understand these configurations. Okay, so here if you see, this is actually a Spark SQL in-memory columnar storage compressed. When set to true, Spark SQL automatically select a compression codec for each column based on statistics of the data. So your Spark have that intelligence. When you enable this configuration, your Spark can automatically select the compression codec. Okay, so this is something, I mean, if you want to remember all these configurations, it is very much difficult, but I will give you few configurations. Okay, I will give you few configurations, okay, which are important in our day in day out, right? So here if you see Spark SQL dot files dot max partition bytes, this is very important configuration. Based on this configuration, your partitions will gets created. Okay, based on this configuration, your partitions will get created. That means the default size of this configuration is 128 MB. Okay, so when you create your data frame, okay, when you create your data frame, your actual cluster in a production cluster, if you are loading 1 GB of data into a data frame, based on this configuration, so how many partitions it will create? 1 G, I mean 1024 by 128 MB. So that means those many partitions will be created in your data frame. Be very, very clear. Okay, so depending on this configuration, your partitions will get created. For example, you want very large partitions, you can tweak this configuration. Okay, so and then this is not needed, and min partition number and max partition number, this always you can tweak to adjust the partition count. Okay, so you can go through these configurations, guys. I mean, the detailed description also has given here. Okay, and here if you see the broadcast timeout, so this is one of the parameter that we need, because in some scenarios you will be broadcasting data frames also. Okay, you will be broadcasting data, not only the variables, broadcast variables we have seen, right? The similar way you will be broadcasting data frames also. So that broadcasting is having some time. Okay, within that time, if it was not able to broadcast, then it will come out. Okay, and then here if you see the Spark SQL auto broadcast join threshold 10 MB, that means there is a concept called broadcast join. Okay, so in Spark we have different types of joins. Okay, internal types of joins, right? So when you are doing Spark joins, when you left, right, inner, these are SQL join types. Okay, but Spark, how it internally joins the data, so that based on that internals we have few uh, differentiations. One is sort merge join. Okay, and the second one is broadcast join. Okay, and the third one is hash join. Okay, and the fourth one is broadcast hash join. Okay, so these are different internal, I mean, how actually Spark internally joins the data. So based on that, we have different segregation. So we don't use hash join much. So internally, Spark default join is a sort merge join. Remember, Spark default join, which is sort merge join. Okay, because sort merge join is very much optimal when it is working with very large data frames. Okay, let us take an example. You have very large data frame and very small data frame. You are doing a lookup join. Okay, in that scenario you will go for a join called broadcast join. Okay, so here let us take an example. Your data frame 1 is 100 GB. Okay, and your data frame 2 is 200 GB. Sorry, your data frame 2 is 100 MB. Okay, so data frame 1 is 100 GB, data frame 2 is 100 MB. Okay, now if you want to join these two data frames, then we have a concept called broadcast join, which is very much performant oriented in this case. Okay, now how we will do that broadcast join? So there is a syntax for it. So in joins you can actually see that broadcast. Yeah, so here if you see, you have okay, so I will explain about this configuration first, then we will go to that, we'll understand. Okay, so where is that auto broadcast 10 MB? Yeah, here. If you see, this is the configuration. Okay, Spark SQL auto broadcast join threshold 10 MB, meaning, so here if you see, it will analyze when you are doing the data frames join. It will try to analyze the broadcast feature, because you already enabled it to 10 MB, right? So it will try to analyze whether your data frame size fall in 10 MB or not. Okay, so if data frame size falls less than 10 MB, then it will automatically treat that as a broadcast join. Okay, and it will load your small data frame into all the executors RAM. So for every executor, that small data frame will be available in the RAM itself, so the join will happen very fastly, right? So that is the reason, when we have a very big data frame joining with a small data frame, we always prefer broadcast join. And the size limit you can actually specify here, the broadcast join threshold, right? So 10 MB is the default one. If you want to increase it, you can increase it. Okay, but you need to have that executors RAM, that much executors RAM. Okay, so this is the automatic way of doing broadcasting. Okay, but explicitly also you can actually specify your broadcast join. I will just give that syntax to you. See here, I mean, how actually we are using this chat GPT, right? See here, this is very simple syntax that you don't need to do much. So you have data frames. Okay, and you have broadcast function, so you just need to use broadcast of a small data frame. Okay, a big data frame dot join of broadcast of small data frame, that's it. So this small data frame will be sent to all the executors RAM. Okay, memory, in memory, and then it will be treated as cached data. Then it will be joined automatically very fast with this large data, because this large data is split into partitions, right? So those partitions will be available in all the executors. Then what will happen, your small data frame is already there in the RAM, and it will read that partitions, large data frame partitions into the RAM, and then it will try to join. Okay, so that is the importance of your broadcast join. Okay, that is the importance of your broadcast join. So here, if you see, you can set your configuration. So we'll see this later. You don't need to worry about it, but you can adjust your broadcast size. Okay, so how much data it can allow to broadcast, right, when it is joining. So you can always adjust that data volume. Okay, so that is about your broadcasting, right? And the next configuration that we need to see is Spark SQL shuffle partitions. So this is very important configuration. When your data have shuffle transformations, let us take an example, join, group by, these kind of transformations. So these transformations trigger shuffle, we know, right? So when it is shuffling, the data needs to be rearranged into multiple partitions. Okay, now before shuffling, your data have 1,000 partitions, and all your transformations are very fast. But after shuffling, you, by default it is 200, guys. Remember, by default it is 200. So it will arrange the data into 200 partitions. Okay, so let us explain that sequence, right? So you need to understand that it is very important. So here, if you see, you have data frame 1. Okay, and then it has 100 partition, 1,000 partitions. You applied filter. Okay, you applied filter, and you applied map, or else you applied some other transformations, let us say case when. Okay, and then you applied with column. Okay, another with column. Okay, now here you applied df dot group by. Okay, now what will happen, so these all transformations were pretty fast because you have 1,000 partitions. Okay, now let us assume you till here you have 1,000 partitions, but when the shuffle happens, what will happen, by default your data frame 2 have 200 partitions only. Okay, 200 partitions. Then you try to apply these transformations, right? Let us take an example, filter and all. Then what will happen, it may be a little bit slow, because your 1,000 partitions got reduced to 200 partitions. That means you have very, maybe you have large data, or else you have oversized partitions. So that may cause processing latency. Okay, so that is why we may need to tweak these shuffle partitions when you have more shuffle transformations. Okay, so let us take an example. Here I have 1,000, and then I may go for 500, because I'm grouping the data, so the data record count may decrease. So your shuffle partitions size, always remember. Let us take an example. You have executors, right? Okay, how we will define optimized shuffle partitions, I'm telling you. Let us take an example. You have executor cores. You have 2 cores per executors. Let us assume 2 cores per executors, and like that you have 10 executors in your entire cluster. So 10 into 2, 20 cores you have, right? So the optimal partitions is 2 partitions per core. Okay, 2 partitions per core. That means 20 into 2. Okay, that means 40. Okay, so 40 partitions. That means in the large data cases, large data or large cluster cases, it will vary. Okay, so usually per executor we give 4 cores. Okay, per executor we give 4 cores. And then in a typical cluster we may have executors vary from 50 to 100 or 200 also, we will see, and 500 executors also you will see sometimes, right? So you can see this. So 50 executor cores into 3 or 2. So optimal is 2 or 3, that is the number. Okay, so 2, if you can give 50 into 4, what is that? 200 cores you have. Okay, and 200 cores into 2, if you give, it is actually 400 partitions, right? So this is how you will derive the number for shuffle partitions. Okay, so in Spark 3.x, or from the starting of Spark 3.x, you don't need to worry about these shuffle partitions. There is a concept called AQE. Okay, there is a concept called AQE. So here, adaptive query execution, we call it as adaptive query execution in Spark 3.x. Spark came up with this AQE, adaptive query execution. If you enable this AQE, you don't need to set any partitioning, shuffle partitions. Okay, dynamically based on the running stats or based on the transformation stats, your Spark derives that number, and your Spark, automatically derive that shuffle partitions number. Okay, so here, if you see here, you have Spark SQL adaptive enabled. So this is a optimized configuration in Spark 3.x. Okay, so here, if you see how actually your partition strategy, post shuffle strategy, what is the size that you need to specify, right? Adaptive coalesce partitions enabled, adaptive skew join enabled. So these are all optimization configurations, guys. So in Spark 3.x, adaptive query execution is one of the parameter, or one of the configuration that they brought, because Spark 3.4 is the latest version, and majority of the real-time projects are still in Spark 3.1. Okay, so in Spark 3.x version, you got this AQE feature, wherein dynamically you can adjust your partitions. Even though you have shuffle transformations, you can actually adjust. The system can actually adjust the partitions by using this AQE. You need to enable these configurations for your AQE. So keep these things in mind, guys. Today we have discussed few important concepts. Okay, one is running the SQL queries on the data frames, and the second thing is we have seen the analytics functions, how we will implement analytics functions on top of the data frames. And we have seen cache and persist. Okay, so if we want to cache our data frames, or if we want to cache our RDDs, what are the different methods that we have? We have two methods, cache and persist. Cache will store your data in memory only, but your persist will allow you to store your data in different storage levels. Okay, memory only, memory disk only, memory and disk. Okay, so memory and disk means if you are not very much confident to about your RAM size, you can always use memory and disk. Okay, okay, so if you see here, cache and persist, right? So how we will implement them on top of the data frames, right? How we will implement them on top of the data frames. So this is very important. See here, df.cache, that's it. Okay, you still can assign it to another data frame, it will run. Okay, so df.cache we will do. Okay, but if you want to do see here, all your further transformations will be very fast. If you run your count on the normal data frame, it will be a little bit slow. But if you do cache and if you do count, right, then it will be very fast, be very clear. Okay, then if you want to do persist, so this is how you will do persist: storage level dot memory and disk. Okay, so if you want to store your data frame in both the places, I mean memory and disk, right, then you will use this persist method. Okay, so here if you see, you have cache, and you applied all the transformations, right? So these transformations will run faster. Similarly, you have persist. So for persist, you need to import one function called storage level. Okay, so this is the difference, or this is how we will implement cache and persist, right? So after that, we have seen a broadcast join, and we have seen few configurations that are needed, right, for us to improve the performance of your Spark jobs, right? And we have discussed about AQE, adaptive query execution. So you can actually, I'm giving you a high level picture on how these things will work. If you have very good data set, and if you can take that good data set and then implement these things, so you will see the difference. Okay, you will see the difference. So that is how you can implement things in this. Okay, so I have a use case for you on data frames. Okay, so I want you to go through this use case and solve it by tomorrow. Okay, so here if you see, I have a scenario: retail sales analysis. So this is a use case that I have taken. Okay, you are a data engineer, and you are given with this retail data. Okay, and you need to derive some business outcomes from this data. Okay, so this is the sales data. Okay, this is the sales data. Okay, and you have sales CSV file, okay, which contains the data like this. Okay, transaction ID, store ID, product ID, quantity, price, and transaction date. Okay, I have given detailed description on each column what it is, right? And you have products data. Okay, products CSV file that you got. Assume that you have loaded all these CSV files into GCS. Okay, and then you have stores data, right? So you have store ID, store name, region, right? So you have these three tables that are coming as your from your source system. Assume. Okay, and the first task, so load and prepare data. Load the sales CSV, product CSV, store CSV files into PySpark data frame. This is the first task. Okay, perform necessary data cleaning. Okay, so if you have any missing values or any null values, or you need to handle or correct anything, you just try to correct. Okay, and join the data frames, right? So join the sales data frame with products data frame on product ID. Okay, join the resulting data frame with the stores data. Okay, and on the store ID. Okay, so calculate the total revenue. Calculate the total revenue. So calculate the total revenue for each transaction, right? So for each transaction, that is quantity into price is the logic for your total revenue. Okay, calculate the total revenue for each transaction. And for this, create a new column called total revenue in the data frame to store this value. Okay, so that means for every transaction, here if you see, transaction ID you have in the sales data, and you have quantity and price. Okay, and have your you need to have your data transformed in such a way that you need to have a new column called total revenue, and that total revenue will be, the logic for it is quantity into price. Okay, quantity into price. So you need to generate that total revenue column. Okay, now analyze product performance. This is another way, I mean another use case wherein group the data by product name and category, and calculate the following: total units sold, total revenue generated, right, and average revenue per unit. See here guys, the use case, the requirements from the user doesn't doesn't the requirements from the user doesn't ask you to doesn't ask you to actually write SQL queries, use case when statements, use group by things. No, they will directly ask the requirement. That's it. So total units sold per product per category. That is the requirement. So now you, based on your technology understanding, you should know, okay, so I need to group by product name and category, and then I need to do this operation. This is how the requirement will come. Okay, you need to think and write your logic. Okay, analyze retail performance. So see here, these are all different tasks. Analyze retail performance. Group the data by region and calculate the following. Okay, total revenue generated in each region, top performing products in each region, store with the highest revenue in each region, right? So these are different tables. I mean, for your understanding, I'm telling you, see, total revenue is one table. Okay, total revenue is one table, wherein after joining you are adding total revenue column, and then you are writing it into one table called total revenue. And then product underscore performance is one table. Okay, product underscore performance is one table which holds product performance related data: total units sold, total revenue generated, average revenue per units. Okay, similarly, regional performance is another table to hold regional performance data. Okay, and similarly, the seasonal trends, identify the seasonal trends, right? Extract the month from transaction date and analyze sales trends across different months. Identify the peak sales months for each product category, right? So you need to identify in which months the sale is very peak, right? The top 5 peak sales, or else the top 5 months which have peak sales, right? So that is one thing that you need to identify. Okay, the peak sales months, right? So you need to identify that. Okay, so and then save the result. So this is seasonal trends is another table you can right. See here, expected deliverables, product performance report, regional performance report, and sales trends report. So this is how your requirement will come. I mean, from the BA, right? So business analyst. So this is how your requirement will come, and then you need to write the logic for it. Okay, so any questions in this use case, guys? I will upload all these CSV files into the Git repository after some time, because I still need to prepare the data. Okay, so I will upload the files into the Git repository and this use case document also in a while, maybe after an hour or so. Okay, I want you to understand this use case first. Okay, any questions here? Okay, fine. So let me prepare the data sets, and then I will upload this use case into the Git repository. So I'll update in the WhatsApp group once I upload the data. I want you to solve this use case by tomorrow. Okay, so that you will get complete understanding on the data frame based transformations. So write the logic on data frame based transformations. Okay, so if anybody feeling complexity in writing data frame based logics, then it's okay, you can go for SQL based logic also, but preferably write in data frame based transformation, so that you will be comfortable in native SQL also, as well. Okay, fine. So that's all I have for today, guys. Thank you so much for joining. Once again tomorrow. Yeah.
Thanks.